Prove that root 3 is irrational. So root 3 is irrational because it is in the form of a set, but we need to prove it. So I'll use contradiction proof. So first let us assume root 3 is rational number. Root 3 is rational number. If it is a rational number, we can write in the form of p by q. So here I'll consider it as root 3 equals a by b, where a and b are co-primes. A and b are co-primes and b is not equal to 0. So what are co-primes? So co-primes are nothing but numbers whose HCF is 1. For example, 15 and 14. See, 15 and 14, they are not prime numbers. Okay, all prime numbers are co-primes, but 15 and 17 are not prime, but they are co-primes because the HCF is 1. What I want to say is there is no common factor. See, already it is in simplest form. So a and b are co-primes. So squaring on both sides. Next step. So squaring on both sides. So root 3 whole square equals a by b whole square. So root 3 whole square is square and root cancel. So 3 equals a square by b square. So 3b square equals a square. 3b square equals a square. So here see very clearly 3 divides a square. 3 divides a square. If 3 divides a square, so if 3 divides a square, suppose 3 divides 81, which is the square of 9. So then definitely 3 divides 9. For example, if 5 divides the square of like 25 square, which is 625, which is 25 square, then definitely 5 divides 25. So in the same way here, if 3 divides a square, then definitely 3 divides a. 3 divides a square, then 3 divides a. So if 3 divides a, then the remainder will be like 0. I'll consider the quotient as c. So let a equals 3c. A equals here I'll write a is equal to 3c, because division rule is nothing but here dividend equals divisor into quotient plus remainder. So you will get a is equal to 3c. So again, like squaring on both sides. Again squaring on both sides. So if you do squaring on both sides, see, I'll get a equals 3c. A equals 3c. So squaring on both sides if you do. So a square equals 9c square. Now here see a square value, I'll substitute over here. This a square value, I'll substitute here. What is a square? A square is 3b square. So 3b square equals 9c square. So if you'll cancel this, 3 times 1, 3 times 3. So I'll get b square equals 3c square. B square equals 3c square. So here 3 divides b square. 3 divides b square. 3 divides b square. So definitely 3 divides b. 3 divides b square. So 3 divides b. So here if you'll observe both a and b, both a and b have the common factor. Both a and b have the common factor 3. See, but I assumed a and b are co-primes, but I got common factor 3. So this contradicts the fact that a and b are co-primes. A and b are co-primes, and the contradiction arises because of our assumption. Arises by assuming root 3 is rational. Root 3 is rational. So therefore, so here you can write hence root 3 is one second. Hence root 3 is irrational. Hence root 3 is irrational. In this way we need to simplify.